Alright, let's look at another polynomial inequality, another example. Now in this example, you can see we already have the factorization given to us, a linear factorization. So it'll make it a little easier to create our graph, right, of this polynomial using its characteristics. So let's go ahead and look at the first step, which is making sure all our terms on one side, which they are. We've set it over here on the left side with these 1, 2, 3, 4, right, linear factors. We got the x plus 1, the x minus 2, the x minus 4, and it's greater than or equal to 0. So we're going to have to, right, find out again when that occurs. All those real number values of x are going to satisfy this polynomial. So let's go ahead and talk about the zeros. So with the zeros, right, we have, of course, the first factor of x. All right, now, of course, x equals 0. There's a 0 of the polynomial. Now, its multiplicity is only used one time, so multiplicity would be 1. And it's odd, so with an odd multiplicity, we know it's going to cross through, right, the x-axis at the x-intercept of 0, 0, the origin. Now, x plus 1, now, of course, that gives us another 0. That equals 0 and x equals negative 1. All right, now its multiplicity now is 2. So again, it's even. So with it being even, it won't cross through, it'll touch, right, and bounce off that point. So it'll touch at the x-intercept of negative 1, 0 and form a turning point. And of course, at x minus 2, right, let's go ahead and look at its 0. All right, x minus 2 equals 0 and x equals 2. So we got another 0 to use. So we're going to put that down here. We'll run out of room there. So we got 2 is 0. Now its multiplicity, again, is what? It's power 3, degree 3. So again, that's used 3 times. It's an odd multiplicity. So like it was at 0, at 2, we're going to cross through the x-axis. So again, at that x-intercept of 2, 0. And then our fourth and final factor that we have, fourth linear factor, x minus 4, of course, equals 0, and x equals 4. So 0, 4, and it's only used one time. So, again, it'll cross through also at 4. All right, so it crosses again at 4, 0. All right, now that's the zeros. All right, now we can go ahead if we want and plot those. So let's go ahead and plot those points. So we have 1 at negative 1, and we'll go ahead and put that on here. It's negative 1 on the x-axis. We've got a x-intercept at 0, so here's 0. We got x-intercept at 2, and we got an x-intercept at 4. So those are our x-intercept locations, negative 1, 0, at 0, 0, 2, 0, and 4, 0. All right, now let's talk about leading term. So what's our leading term of this polynomial? Now remember, how many factors do we have? Now let's count them up again. We got 1x, right, factor. So 1, and we have 2 of the x plus 1s. That's 3 total. 3 of the x minus 2s. So we've got 6 total factors, and then the x minus 4. So there's 7 linear factors here. So this is a 7th degree polynomial. And of course, leading coefficient is negative. So our leading term is negative x to the 7th power. So with the leading term test, our leading coefficient, right, is negative 1. That's less than 0. And our degree is an odd number. It's 7. So with it being a odd degree polynomial, right, we're looking at what? Odd degree polynomial, we got the ends doing opposite directions. So we've got, what, negative coefficient. Now with it being negative, right, we know that left tail will go to infinity and right tail will go to negative infinity. So the ends, right, we see the end behavior based off that odd degree. So let's go ahead and form this graph. So looking back, now remember, as we're coming from left tail is coming from infinity based on this odd degree with negative leading coefficient. Now at the x-intercept of negative 1, 0, we're not going to cross through it. Remember now we had negative 1. Right? Let's go back. At negative 1 we had a even multiplicity. So there's 2, right? So it bounces off it. and then it goes up. Of course, it's got to come back down and cross through at 0, 0. Remember, 0 had a odd multiplicity, so it'll cross through the x-axis at that location. And then at 2, it crosses through, come back up, and go through 2. And then, of course, at 4, what's it going to do at 4? At 4, it's going to cross through, right, because it's odd multiplicity. We only had one even multiplicity, and that was at -1. And, of course, we knew the left tail would go down forever to -infinity. So there's a quick sketch, right, of our graph. Now, with that said, let's talk about, all right, the inequality. So let's look at it here, a different color. So what do we want with this graph? We want to know when it was greater than or equal to 0. So where is it positive? So where are our positive function values? So looking at our graph, let's shade it in. So greater than or equal to 0, of course, -1 it equals 0. But our graph here, we have positive function values. Right, all the way in here. We'll highlight it in blue. Right, until we get to 0. Of course, 0 is the next intercept. We're going to include that one. Now, between 0 and 2, what's our graph doing? Between 0 and 2, we got negative values. Right, it's less than 0. But yeah, we're greater than 0 in these locations. All right, so again, greater than 0. Greater than 0. Now here we're less than 0. So we don't want those. Right, now between 2, now 2 is the x-intercept. So it equals 0 there. We want to include that. Right, it's positive all the way until we get to 4. Now below 4, it's less than 0, right, on this side of the x-axis. But yeah, it's greater than 0 here. So you can see where our solutions are. So I've highlighted in blue here. So we're looking at this graph, shade in the x-line where we just followed it, right? So all x values less than or equal to 0. So in here, a graph is either positive, on the positive side of the y-axis, or equal to 0. And between 2 and 4, it's positive. So as we look at our solution set, all right, let's put it in interval notation. We got all x values less than or equal to 0. Right, we need a bracket on that. We got to include it because of the equality. Or from 2 to 4, all x values greater than or equal to 2, less than or equal to 4. That's greater than or equal to 0. So there's our solution set for this polynomial written in, of course, interval form, our preferred form. So I hope this helps, again, these type of polynomials.